Okay, students, so today we'll be doing another experiment that is on flame photometry. It's another analytical technique which we can use to find basically alkali and alkaline earth metal, as we discussed in the lecture as well. This particular technique basically is an emission spectroscopy. You have done all those absorption spectroscopy. In this one, we'll be recording emission. That's why I say it's not only called flame photometry, also called flame emission spectroscopy. So this is an instrument which we are going to use. This comes in two parts. One being the main unit, which is flame photometer. The other is a compression unit which gives air at a particular pressure. So this is being connected through this pipe to this instrument over here. Then we have a gas knob here with which we can control the gas flow. In this particular instrument we are using this is the knob here, the gas knob. We are using LPG gas, but there are flame photometer which comes with acetylene as well. That's not a matter of concern here. We have a flame photometer with LPG unit. So to work with this instrument, what we have to do first up is to ensure that this pressure is between 0.2 to 0.6. I've kept it at 0.4. If it is not at the point between 0.2 to 0.6, we can always rotate this knob to bring it to your desired value. So after putting it between 0.2 to 0.6, where it works best, so we'll be working with the instrument. I've already ignited the flame inside, which can be seen through, you can see through this window. Never watch from the top. This is the window to watch the flame, and it should be blue in color with cone shape, right? So nice blue cone color shape flame should be there to work with. This is the chimney, and one can sometimes the flame can come on top through this opening, so one should not see the flame through this, rather always watch through the watch window. Okay, then we have this filter here. When you are to find sodium, you will keep it at sodium. If you have to find potassium, you bring it to potassium, because if it is at potassium, the filter will only allow the potassium wave to pass through, right? And if it is sodium, on sodium, it will allow only sodium to pass through. So that is the role of the filter. Then we have this instrument with multiple knobs we'll be using as we work with this experiment. So the first thing to do is to take distilled water. So in this particular cell, I'm taking some distilled water in the cell, and I'll be dipping this capillary in the distilled water. With distilled water, my display should be 0. And I'll start with sensitivity 1. Sensitivity at 1, display with distilled water should read 0. If it is not 0, you can always adjust using this knob. I'm bringing it, I've disturbed it so that I can show you. I'm bringing it back to 0. So this is now adjusting at 0. Now the next task is to calibrate this instrument with a standard solution. So I'll take a sodium 50 ppm solution. This is basically made using sodium chloride, but this is sodium ion 50 ppm solution. So I'll take this solution and in another container with another cell, and I know its concentration is 50 ppm, so my instrument should read it 50, else I have to calibrate it. So I'm dipping this in, and I have to wait and see where it goes. So it's reading 63, so that means I have to adjust to 50, so that instrument is calibrated to the desired value, which is my my standard solution value. So I'm bringing it to 50. Once it is being set at 50, you can work with your test solution. So I'll take this out. Okay, one more thing is, with sodium solution, the flame color should be yellow. The sodium ion gives yellow color. So you can see that blue flame has now changed to yellow. Now you take out the capillary and put it back in distilled water. So I'll be putting it back in distilled water. I'm waiting for some time so that whatever solution is there in the tube can go pass through the track. Okay, so it's back at 0. So that means I'm ready to find out the concentration in my test solution. This is my test solution wherein I need to find out the concentration of sodium ion. I'm dipping this capillary again, now this time in test solution, and this should give me my result. So which is 33 ppm. So that's about it. So we work with sodium. It's giving result for sodium because the filter is at sodium. So for the next part of the experiment, which is our next part, is to find out the concentration of potassium. So I'm putting it on potassium filter. So this is now on potassium filter. I'll take out this capillary tube and I'll go with the same series of steps. So I'll take distilled water and dip this capillary in distilled water, but I'm waiting for some time so that the tube is clean before I dip it in distilled water. So it should go back to 0 as we have to adjust it to 0. So you can see that this is stopped at 2, so we can use this 0 knob to bring it to 0. So now I'm ready for my potassium ion concentration measurement. So I'll take this tube out and dip it in a standard potassium solution. I have 50 ppm standard potassium solution with me. So I'll be using that solution and my instrument should read it 50. If it's not reading, we have to calibrate it. That's the step I'm doing basically, the calibration of the instrument. So I'm dipping the potassium solution and you see it's reading too high. So I have to adjust it to 50 by rotating this knob here. So the instrument is adjusted to 50. I'm taking the capillary out and will put it back in distilled water, but I'm waiting for a while so that the whatever solution is there in the track goes into the flame. I'm not disturbing our requirement. I forgot to show you the color of potassium ion. Basically the flame color changes to purple when there is potassium. So with distilled water, I can see the display is already at 0. So I can take this capillary out and put it in the test solution again, which contains potassium as well as sodium. So it goes in there, but since the filter is at potassium, it will only record the potassium value. So that means our test solution contains 39 ppm of potassium, and we tested sodium as equal to 33 ppm. So that's about this experiment to find out sodium and potassium concentration. And just to show you the potassium color, I am putting it back in distilled water, so and then in potassium, because we missed at that time. So right now with the distilled water, the color of the flame should come blue, nice blue pony color, and then on putting in the potassium solution, it should show a purple color. Violet color. So that is an indicator that potassium is there. Although we are not really concerned with the color here, we have already found out our results. Thank you everyone.